Well, that's a great way to kick us off. We are so pleased that we have Dr. Mary Prunicki here today as today's speaker. I think most of you know Mary as Director of Air Pollution and Health Research at the Sean Parker Center of Allergy and Asthma Research. And today she's going to be leading us in a presentation and discussion about the health impacts of smoke exposure. What do we know? So Mary, tell us what we know and what we need to know.
Will do. Can you see my slides?
Yeah.
Yeah.
Mm-hmm. Yes.
Yes.
Okay. Let me just start it here. Okay, are we good?
We're good.
Okay. So I'm going to give some updates on the research that we're doing and what we do versus we don't know regarding smoke exposure. And so feel free to stop me at any time if I've skipped over, something that I should have reviewed. So just to go over, when we inhale any type of particle, bacteria, virus, the size determines how far it goes down into our respiratory tract. So when we're talking about particulate matter, it depends on the size. So coarse particulate matter is, PM10 or greater, and that only goes partway down the respiratory tract. But if we're talking about fine particulate matter like PM2.5 or even ultrafine, it can go all the way down to the base of the lungs and cross over at the level of the alveoli into the bloodstream. And in the alveoli, that's where we see some of the cells that we study in the bloodstream. Some of these cells secrete biomarkers that we can pick up in the blood. And we don't do it, but you can actually do a lavage of the respiratory tract and get some of these cells in the sample and do it that way. So once for example, the PM2.5 crosses over into the bloodstream, it wreaks havoc on the body. You can see increases in cancer, such as lung cancer, increases in inflammation, causing asthma exacerbations, COP exacerbations. You see changes in the cardiovascular system, so increases in heart attacks, strokes, arrhythmias. Obviously, problems with allergies and autoimmune diseases, and that's the primary focus of our lab. Other disorders like diabetes are impacted by pollution. And then you can even get some neurologic changes, and then of course, different types of cancer. The reason, we're talking about PM2.5 is that like 80% of wildfire smoke consists of PM2.5, although it does consist of lots of other toxins. So just for ease of study, and the most research has been done on PM2.5, we'll kind of focus primarily on that pollutant, although it's good to look at the other pollutants too. So if you look at this satellite-derived PM2.5 image, United States, you can see, there's in general poor air quality in the Central Valley and then over on the East Coast. And worldwide, though, overall, our PM2.5 levels look pretty good compared to some other parts of the world. And, some areas can get up to, 80 micrograms per cubic meter of PM2.5. And so in our lab, what we typically do is we collect blood. Then we do a processing where we separate the plasma out from the blood cells, and then we look at those two components in different ways. And I'm just going to kind of briefly go through some of this and get more to the types of research that we're doing. This is just an example. Once we figure out on the left the different types of cells, we can look at the proportion of cells. We can look at the associations of these different types of cells with the different pollutants, and also the varying time level related to exposure. So for example, in this most recent paper, we were looking at children in Fresno, ages 6 to 8, and we were able to show that certain cell types are associated with, very recent pollution exposure. Other cell types, it takes longer. So 1 day versus, 3-month exposure to see shifts in different types of cell types. We look at something on the right, we're looking at methylation levels. So we're looking at the change in the regulation of the immune genes. And what you can see is that it depends on the pollutant, and then it depends on the duration of the exposure for the degree of changes in gene regulation that we see. And this is just kind of to show that even in kids 6 to 8 years old, we can see changes in their immune function just from air pollution. But we'll go into the wildfires. So I kind of divided up the talk to talk about some of the wildfire research, but then I'm also going to touch on COVID because that is impacted by air pollution studies or air pollution levels. And then we've started to look at microplastics and PFAS levels. So I'm going to throw that into. I don't think I need to tell this group that wildfires are increasing and is strongly linked to climate change. These are figures that are about to be submitted by Rebecca, postdoc in our lab. And what he's showing is that not only the cumulative number of smoky days are increasing in the Western states, cumulative number, and then just cumulative increase in the amount of pollution exposure that we're experiencing. But we all know that from last fall. And in the study that he's about to submit for publication, we looked at just the Stanford hospital data, and we looked at the 2-week period prior to the wildfires in August, September, during the wildfires, and the 2 weeks after, and compared what types of diseases came in and what were the age groups experiencing those different disease outcomes. And what we found replicated what we already know for the adults, in that there's increases in respiratory and cardiovascular events. Also in the younger age group, there was increase in respiratory events, so that confirms prior studies. What was new was that there are pregnancy-related outcomes related to the wildfires that occurred last fall. And so this will have to be followed up further, but it does make sense that exposure to the wildfire smoke unfortunately does result in loss of pregnancy. We also looked at, we did a baseline level and then looked at these same people, how they rated the wildfires last fall. And there were significant differences in things like burning eyes, burning throat, significant differences in burning eyes, burning throat, fatigue, and headache. I think the most interesting finding is the fatigue. Why experiencing the wildfire smoke would cause increases in self-reports fatigue. We also looked at mask usage and found that the majority of people did not wear an N95 type mask. That could have been due in part to lack of availability, but there were some reported that they actually had access to an N95 and chose to wear, a hospital type mask or bandana instead. And so I had presented this slide before. We know that wildfire smoke increases asthma and COPD exacerbations and other type of respiratory events. That's been well vetted in the literature. And for cardiovascular health, it's been shown that pollution exposure is associated with increase in cardiovascular death and outcomes, such as the heart attacks and the arrhythmias. There's evidence now suggesting that the exposure results in high blood pressure, diabetes, and the non-fatal strokes, and heart attacks, and also heart failure. And then there's more research being done on arrhythmias. and thromboembolic disease, which are like blood clots. So if we look at the different standards across the world for PM 2.5 levels, we can see that when there's more strict standards in place for PM levels, there is a reduction in there's less cardiovascular disease. So this all makes sense. In our own studies, even looking at teenagers, we can see differences in cardiovascular biomarkers depending on how much PM 2.5 they're exposed to during a wildfire. And also there were significant differences in how much pH they were exposed to during a wildfire. So that all fits. I'm going to skip through some of these for sake of time. This is kind of interesting. When I showed you a picture of the alveoli in the lung, they are lined by macrophages, and this is just a picture of them. And those bigger circles are macrophages, and those black dots are particulate matter. And so you can see that when someone inhales the particulate matter, the immune cells in your body, the macrophages in particular, try to engulf them and digest them and get rid of them. And this process and the activation of the macrophages causes systemic changes in your body, changes in your biomarkers, which cause different types of inflammatory problems in different organ systems. And we also know, although it's an area of investigation, that all smoke is not considered equal. We know that particulate matter, the composition depends on what's being burned. So that's why, we're interested in comparing a wildfire in Yosemite versus when a town is actually burned down and there's other chemicals and plastics being burned. That's, so a structure fire is different from a wildfire and different probably from a prescribed burn. And so that's one area of our research is we would like to be able to quantify the differences and compare it to the immune changes that we see during exposure. And this is a study just in mice showing that indeed, if you even burn different types of trees, you're going to get a difference in the amount of immune cells being activated. I put in a couple slides on COVID-19 because a lot of the conditions that are associated with more severe outcomes and in hospitalizations with COVID are also associated with exposure to wildfires, which makes sense, in part because we're talking about some of the same immune compromise. And for example, we know that when someone smokes, so that type of pollution does increase your chance for getting a respiratory infection, and it also increases your chance for getting COVID. And this is being shown on the cellular level. But in general, we know when there's an increase in pollutants, you become through activation of things like your monocytes and other immune processes, you become more susceptible to any type of viral or bacterial pathogen. And COVID is just one of those. And if we look at some of the maps, we can see on the top the average PM 2.5 levels. I believe that's from 17 years average. And then if you overlay it with some of the data from the COVID-19 deaths, they look kind of strikingly similar. And there's been several studies showing that there is an association between exposure to air pollution, of which wildfire obviously contributes, and COVID rates. And these are just some of the details. One paper, which there's a little bit of controversy about, does show that when you're exposed long-term to elevated pollution, you have an 8% increase in mortality for every unit increase in PM 2.5 that you've been exposed to. So that's fairly remarkable. I'm going to talk briefly, if that's okay, about microplastics. That's you know, when we talk about wildfires, there's also an increase in microplastics. Microplastic is kind of defined by any plastic particle that's less than 5 millimeters in length. It's been, you know, well documented that microplastics are a problem globally. They're a problem in many areas, and if you look at exposure just in general, we're all exposed to a certain level of microplastics from various sources. The primary one is air, but there's also, in addition to inhalation, there is dermal exposure, so the skin, and then there's also ingestion. And this is just kind of a diagram showing the different ways that you can be exposed to microplastics and some of the negative impacts it has on your body, including cancer, increase in inflammation, and the toxicity in general. I'll skip through that. That's about the same. One estimate is that we consume about 50,000 particles per person per year of microplastics, which I believe is like eating 4 credit cards. There's some analogy to how many credit cards you would eat to compare the amount of microplastics you're exposed to. You know, you're exposed if there's dust on the plate. Some of that may be microplastics, increasing your consumption. It's also in certain foods, and when animals, you know, eat the microplastic and you eat the animal, you're getting another dose of microplastic. And there's other ways to ingest the microplastic. There's also the inhalation, which is, you know, more important when we're talking about wildfires. And it, you know, again, tries to be cleared by the macrophages in the body or other methods. It causes inflammation. You know, there's been studies finding that you can see microplastics sometimes on lung cancer biopsies. And then for skin exposure, that's considered less important, but it is a way that we are exposed to it. It's apparently part of appliances, so sometimes we're exposed to it daily and we don't even know it. And then, you know, it's on our hands, and if we don't wash our hands, and that's a problem. And in the body, they think that the way that the microplastics is causing that toxicity is through oxidative stress. And so it's also increasing the amount of chronic inflammation and rates of cancer. I'm not going to go into the immune part of it too much, but this is just a summary of ways that we're exposed to the microplastics, food dust. It's in medicines. Synthetic clothing is a big one, cosmetics, and we're going to talk about, when I talk in a minute about the firefighters, another way that they're exposed to it. Once, from whatever route it is in your body, we see inflammation, we see increases in cancer and other negative outcomes. And I'll come back to the microplastics in a minute. There's also, we're starting to look at PFAS levels in firefighters and heavy metals. When we talk about particulate matter, heavy metals can kind of tag on to the particulate matter, kind of like a hitchhiker. And so depending on what's being burned, it's important to also look at the heavy metal levels. So what we're doing is we're looking at firefighters and age match controls. looking at the amount of smoke that they're exposed to, looking at the heavy metal content of their urine actually, looking at the heavy metal content of the clothing that they wear, looking at the cytokines in the blood, and other types of biomarkers that we're able to assess. And you know, the key difficulty is finding an algorithm that can use all the biomarkers and all the data that we're able to collect to kind of predict, you know, what type of immune fitness score all of this exposure results in. And then, you know, if we're able to do that, you know, for example, for a given firefighter, we can say, you know, you're at this level of immune fitness, and, you know, here's the target that you don't really want to cross before we start to see increases in things like cancer. So that's kind of the overall goal of our research. The other thing that we've been doing in the lab is we've been looking at heavy metal levels in the blood. We looked at a group of kids, and we looked at when we're using a method called CyTOF, which is where we take the blood and we tag it with metals and run it through a CyTOF machine. We looked at the open channels where we're not tagging the metals to see, looking at the blood, what types of metals we are able to measure. And this is not published yet, but interestingly, if we look at lead counts, we can see that the groups that had higher lead counts had increased activation on the right of various types of immune cells. So that means that, you know, you're having increases in lots of inflammatory processes, which is not good, which can lead to other diseases, including cancer. On the left are a group of kids that were exposed to a lower level of lead. So this is kind of a novel way to look at heavy metal levels. You can look at it in the plasma in general, but to look at it in the blood along with when we're actually counting and determining the cell types is kind of exciting for us. And lastly, last week actually, we started working with a group to potentially look at the amount of off-gassing that occurs from the garments that the firefighters wear. So on the table on the left, you can see those are old, they call them turnout coats. And those turnout coats are not PFAS free. PFAS is used as a water barrier. And the concern obviously is that these firefighters are getting unduly exposed to PFAS when they're wearing their gear to fight the fires. And so we're comparing old coats to, if you look on the table in the back, there's a new coat. I guess I should have gotten a picture of a new coat that's supposed to be PFAS free. But the fear is, did they trade out the PFAS for just another type of toxicant that is going to be harmful to the firefighters? So we decided to look at the off-gassing. We don't have the results yet, but we're looking at things like formaldehyde levels, methane levels, and then the typical gases to see if there is a difference of what the garments are giving off. When we talk about PFAS, it's a forever chemical. So very, very slow to break down. Once it's in the environment, once it's in your body, it's going to last a very long time. Things that PFAS can cause are increasing your cholesterol levels. It can change your liver enzymes, increased risk of kidney cancer, and also testicular cancer. And the notable thing about the testicular cancer is that's the #1 cancer in firefighters. And so it'll be interesting to look at the correlation between the level of PFAS in their blood and their exposure. We also swab the coats for PFAS levels. And I'm just going to finish up with a recent study that came out looking at PFAS levels and microplastics at the base camp of Mount Everest. Apparently, there was a researcher that wanted to look at water quality And so they were sampling, and what they discovered at this base camp was that it was very high in microplastics and PFAS levels, especially PFAS and PFOA. And they think it's coming off the climbing gear, among other things, for the climbers. These two chemicals have been used since the 1950s for various things like the stain and water repellent, but also in food packaging, in carpeting and firefighting foam, which has now been all out in the US. But it's still used in other countries. And, there's the concern that as more of the snow and the glaciers melt, well, we have increased exposure to these forever chemicals and to the microplastics. So I hope that was a quick overview of the kind of where we're at with some of the wildfire research. And I'd be happy to have a discussion or answer any questions.
Thanks so much, Mary. That was really illuminating, a little bit depressing to me talk, but really just very informative to some things I know I've heard you speak on, and some new stuff today. So thank you for that talk, and
Sure.
I'll open up for questions. I think we should have a very lively discussion about some of these things.
Well, I'll kick it off. So, as you know, I'm more interested in what we can do with your information to protect people. So it's pulling you a little bit out of the research context you're in, but things that we have talked about. So if we are faced with a future in which we're going to have prolonged exposure to the smoke, it's pretty clear that you can't really put people in school with N95 masks, and we already see that that's been problematic. So talk a little bit about whether the answer is to work more on the filtration systems that we have indoors. Is that the key, is to improve those? And do they cover all the different possibilities you're talking about? Because you started out with PM 2.5 and that's what we were kind of focused on, but now you've added in all these other things, some of which are related to fires. Right. So what are we talking about here, Mary? Are we talking about something that is at a level of air filtration that we don't have right now as a technology? What are we talking about if we're trying to protect kids? Because I mean, that's the disturbing thing, is that you're talking about these effects that are hitting on very young children. So if we're going to protect the schools, or we're going to protect where they play or their indoor house, what level are we talking about? Is it something more than what exists currently?
Well, it's certainly more than what exists as a standard currently. So I think the challenge is, even in adults, N95 masks aren't the end all and be all. They don't, filter out the gases. They just filter out their particulate, which is good, but to expect kids to be able to wear them and them to be effective isn't realistic. So, whether it's immediate intervention with air purifiers in classrooms, or it's a combination of that in getting the HVAC systems in schools working appropriately, or is it going into a school and having a clean room, a clean gym, that if the air quality gets to a certain level, the kids can at least go there and have, if it's not affordable to do it per classroom. But I think one of the challenges is there's no standardization to even measure the air quality inside of a school. So I think until that is done, I think that needs to be part of it. There needs to be some type of uniform measurement of the indoor air quality.
Yeah, so if we, so one thing we tell the rest of the group that we're trying to do is get a hold of a school district that would be willing to allow Mary to go in and measure the air quality if you have certain kinds of air systems. But I mean, at the start point, isn't there just the whole question of in a laboratory knowing, couldn't you simulate the relative effect of different types of technologies to start with, so that you know what the ideal was, and then you can look at what's going on in the schools and figure out what to implement. I mean,
Yeah, I mean, in the lab, it would be hard to get IRB approval to just expose people to smoke. So that's why, for example, the study in the beginning I talked about that happened in Fresno with the kids, it is air pollution, although we have some that are looking at fires. But, looking at groups that are naturally being exposed to these different levels of particulate matter, we can see changes. We can see changes in their immune cell composition within a day of exposure. So we know that we have to do something. We have to intervene in some way, because it is there's no low bar where they can be exposed for 10 days and then we worry. Any exposure has the potential to be detrimental, and even one big exposure can even obviously cause an asthma exacerbation, but some studies have shown that it can actually cause asthma in a child. So
I mean, just even trying to figure out, let's say you get the schools, you don't know how the child got to school. You don't know what the child did at home. So it's going to be hard to figure out how much of what you're observing in their systems, even assuming you got their blood types, was due to the exposure in the school, unless you somehow could make everybody stay at the school. I don't know. I just don't know how you would control for all these other things. I mean, you could put some sort of tracker on people, but that doesn't tell you whether they're indoors or outdoors, or, so I'm a little worried about how you would actually know what the impact of the school environment is when you go to the school officials, because they're going to resist paying this much money. I mean, what we're talking about in terms of air filters would be a fairly expensive investment on the part of the schools. So you have to convince them that it's worth it.
If I can actually get involved in this discussion, I'm really curious.
Yeah,
I
sure.
think I have an easier question for Mary. It's like, so do we have some confidence in what, say, molecule or a blue air purifier, that if you could distribute them to everyone's homes and have those, is the current technology sufficient to protect us from burning microplastics and toxins, or is there still a lot more research that needs to be done to know the effectiveness of technology, regardless of price tag? So is the technology out there that would be deployable in schools and homes to
I think
mitigate this?
Yeah, so there's the research showing that it's, has a negative impact on our body. There is not a lot of research showing, and we know that the intervention will filter, whatever it is we're talking about. There's not a lot of research, with a randomized controlled trial showing that, an air purifier or, whatever a mask actually causes a change in your ability of your immune system or your health outcomes. There's very little, because for one, it's very hard to do. And then there's the ethical portion of it. You can't take children and if it's available to everybody and say, no, sorry, you go sit outside. I mean, it's very hard to do that type of study. And I think at some level, we have to just take what we know happens, in the body, take what we know the equipment can do, and just do it and start measuring the groups as it's being done to unfortunately the groups that do not want to do it or can't afford to do it or whatever it is, and make the comparisons that way. But I don't think it's feasible to make the comparisons within, it's very difficult to make those comparisons within individuals.
And then back to the N95 masks, right? Has anyone made some advances on standardizing it for kids, right? Isn't that another issue that I understand? Right,
Yeah.
there's N95 masks that work well for the adult population, but there aren't that many for kids available, let alone during a pandemic or not. That's my understanding, at least.
Right.
Do you agree with that?
They do have some. I mean, the seal is what's key. And so even for adults, if you have facial hair, the seal is not that effective. And it's hard to leave on even a non-N95 mask all day. So to have something that's really sealed appropriately is, especially in kids, is not, I don't think, very realistic.
No.
Yeah.
And then there's the issues of equity. Are we going to find, because we don't really know what the indoor air quality is like in different schools, are we going to find that the more well-off schools have the more airtight buildings, and those kids just aren't getting exposed as much as the lower income kids that don't have the airtight buildings.
Good points. I would suspect that is unfortunately the case. Bruce, do you have more, or can I open it up to anyone else? This is great.
No, it's open. It's open. Yeah.
Other people want to comment on.
Mary, I think you put everybody into a deep funk here.
Or sleep.
Hi, Mary. I have a question. When you talk about air quality levels from wildfires affecting pregnant women, what does that look like? Is it that if they're exposed, how long do they need to be exposed to? What part of the pregnancy do they need to be exposed to? Or,
yeah. So
and what effects does it have on the pregnancy? Do you think it causes miscarriages, or does it increase its intensity?
Yeah, in what we're about to submit, it looked like it caused an increase in spontaneous abortions or miscarriages. So that would be early on. There's been some studies that have already come out showing the association with wildfire, and it depends on what trimester they're in when they're exposed, whether or not it causes preterm birth or decreased birth weight. So I don't remember off the top of my head if it depends if you're in the first, second, or third trimester, what type of outcome is more likely with the exposure.
Thank you.
Mm-hmm.
Iris has a question.
Go for it, Iris.
Mary, thanks for the presentation. One thing that Bruce and I did very recently is we looked at people who experience wildfire, within like 3 miles or 5 miles of their residency, and then people who experience smoke, the number of days they experience smoke. One thing that we noticed is that people who experience fire, that personal experience actually affect their attitudes towards different adaptation strategies.
Okay.
So, but the smoke exposure to smoke actually has no effect, absolutely no effect on people's attitude or towards different policy options. So and then in 2020, I think we put out another study that we tried to kind of give people information about if these are health consequences of exposing to smoke. And then I think, if I remember correctly, I don't think we find a treatment effect. There's no information effect. People seem to kind of brush it away. Okay, but that doesn't really change opinion. So I'm kind of curious. If we put you in an elevator with someone who is a climate skeptic and who absolutely don't believe in smoke, to affect health, and in 1 minute, what's the most convincing evidence or most convincing argument that you could have to convince that person that you need to worry about smoke inhalation?
I think the most shocking study that I've seen is that when you're exposed to smoke, when a community is exposed to smoke, there was a study that showed that there's an increase in sudden cardiac arrest. And it is in ages 30 something and up. So we're not even talking about 60-year-olds. And so for a sudden cardiac arrest, you basically drop dead on the spot. Your heart just completely stops. And most of those people don't make it even to the hospital. They're, if the ambulance, comes, they don't, I think 10% maybe make it to the hospital, to the ER. And those statistics weren't looked at previously because they're not counted in typically in the ER visits or the hospital admission because they die in their home or wherever they're at. So I think that's pretty shocking that that young of an age group can actually be impacted by the smoke.
Yeah, I mean, the good news is that when we did this study in 19 and 20, there was a general increase across all categories in the use of some form of protection like masking. So it does seem that if we have more of these lengthy smoke exposures, there's the possibility that people will actually get the message eventually. There is some learning going on there, but it's very slow. And the disturbing part of it is that it looks a lot like the reaction in the masking, with heavy socioeconomic and partisan differences in the way they screen the information. That's an inference because we can't prove that, but there's definitely, in terms of the steps they're willing to take and their belief that it's very harmful, there are strong partisan effects, education effects, etc. So it does look a lot like some of the stuff we've seen with the COVID reaction.
Mary, can you actually follow that up? Because you mentioned that in your study, you did interview people, right, about using N95 masks. And you said, I was shocked that some people had them available and they chose not to use it. Can you elaborate or maybe reflect on what Bruce just said? Do you agree with what Bruce said in your findings? About personal preferences?
I do, but I'd have to go back and look at the numbers. What surprised me is, that group that we had a baseline for and then we resurveyed, those were primarily Stanford employees or college students, so well-educated people that probably had access to an N95, or if not, was educated enough to know better, that apparently that wasn't enough to, I would have thought that there would have been a higher percentage of people using the appropriate mask.
Wow. That's even more depressing, but that's
yeah, I think we looked back and looked at, was it the college kids that are just kind of being, cavalier or what? And I'd have to go back to remember exactly. But I was a bit surprised that I don't think people realize that any exposure to smoke is bad. It doesn't have to be long-term.
Well, I really appreciate it. Again, I think, I'm not sure who came up with it. I know you and your colleagues very often use the SIGGIs, right?
Yeah,
denotation,
the Australians. Right? Yeah.
So you maybe can recount that to the audience. I forgot the numbers, but it's pretty astounding, right? Taking air quality index numbers and putting it into SIGGIs.
Yeah, let me think for a minute. So I think it's that for every increase in 10 micrograms per cubic meter of PM 2.5, I believe it's like smoking 22 cigarettes. I'll email the group if you want. I don't know if I'm remembering it correctly. But yeah, when Australia had their fires, they would talk about the SIGGI index and how many cigarettes it was like smoking when they went out, which I think makes it more real for people to talk about it that way.
That was my experience. After hearing that, I shared that with relatives and friends, and they're like, oh, and they started masking up like during the wildfires. That really was compelling, because I think people do, as a general, they acknowledge cigarettes are not good for you, even if you're addicted to them or not, but they acknowledge that. So
right.
Maybe that's a public service to do, is really to publicize how they're linked.
Right. Yeah, I mean, I think if we could do that with a lot of things like breathing exhaust fumes, or having idling cars at the, pickup for for school. If we could relate it back down to cigarettes, it would probably be pretty effective.
Yeah, we're probably in the same position we were with secondhand smoke. Some of you are too young to know this, but there was a time when people were shocked back in the 80s to find out that secondhand smoke was as dangerous as it is. And it took a long time for people to be convinced. So we probably should look at that case study, how that got changed and how people's attitudes, but you have to come up with a solution, Mary, because once we scare the bejesus out of them, we have no way to. I mean, the problem with the N95 mask for kids is also for adults. A lot of people just find wearing it for a long period of time, like going on an airplane ride, is just a horrible experience, or trying to exercise with it is a horrible experience. So it's just hard to believe that the N95, if we're going to have 3 weeks of this, is going to be the solution by itself. I think it's got to be the air filtration systems.
Yeah. And to me, I mean, I could be totally wrong. It seems like, especially in the lower income communities, investigating whether or not a gym can be turned into a clean air facility, because if the air quality is that bad, maybe you want the kids to stay there overnight and let the families come and stay there overnight and let the kids run around. And classrooms, you wouldn't really be able to do that as well. And it would be more expensive, I would think. So,
yeah, we'd have to figure out, I mean, that's the other, you could imagine doing that for people that are in close proximity and have the heaviest doses of smoke. Because my memory is that the further it travels, it's a little, the level of the whatever we call the PM 2.5 toxicity elements diminish as it over distance, right? So otherwise you're shocking that you take the whole Western region. I mean, some of this smoke is going across 3 or 4 states. Are we really talking about shutting down, or the activity of three states? I don't know.
I mean, the smoke does dissipate, but also as the PM 2.5 stays in the air, it ages and becomes more toxic. So I don't think we really know.
All right, Mary, come on. You got to have something positive.
She's smiling. We got to end this on a high note here.
There's a lot to figure out.
I want to respect people's time. We are at 1:22, and I'm happy to have Mary stay on for a few more questions. But I want to ask the audience if they have any parting question, because I know Bruce and I sort of got really wrapped up in asking Mary questions here today. Are there any questions that you have pressing? And of course, you're free to log out whenever you want.
Yeah. Or send her an email if you got a good suggestion.
Yeah, no.
Yeah, please.
Well, Mary, thank you for a very stimulating talk. I didn't mean to show disrespect saying it was depressing. It's sobering. I should say it's very sobering information you presented us today. And it does sound like there's a lot of work, which I guess the good side is it keeps us employed, right? We have things to work on. So,
that's right. Yeah. Well, thank you for having me. I appreciate it.
Well, it's great having you. All right.
Good job, Mary. Yeah.
Thank you.
See you guys next week.
Okay. Bye-bye.